Hi there, my name is Ferruccio, and today I'm going to talk to you about Clojure and the maker community, which are two things I'm really passionate about. So, starting out, I'm a control engineering student in Milan. I work also as a full-stack developer for a company called Creators Never Die, which is mostly a JavaScript shop though, so I don't write much Clojure for a living. But last year, after reading Hackers and Painters by Paul Graham, I fell in love with the idea of starting to code with a Lisp. So I first started coding with Common Lisp, but then as I couldn't build anything actually useful with Common Lisp, I found out about Clojure for the Brave and True. I really liked the tone of the book, and it got me started with Clojure, and I started building some products with Clojure. So yeah, in the night, I built some products, mostly for fun, sometimes for profit. And why though? Why do I spend my free time building software products? Well, this is because I got involved with the maker community, which is an online community that is based on some core principles, which are the fact of being completely bootstrapped, so build your own products without taking any external funding, getting your hands dirty, trying to design, think about a product, think about sales, and do everything on your own as like a learning experience. Also, another core principle is the fact that when you are a maker, your goal is to try and reach profitability as soon as possible, to validate actually your idea and to actually measure how impactful and how much value your applications are generating. The best part of this community is the fact that there are people from all over the world, from all the most different backgrounds, working on the most different projects, and they're super helpful with you. For example, someone that comes to my mind is a friend called Ethan. He's a 15-year-old from Australia, and he's building a Kanban mail, which is a mailing application based on the Kanban board concept, and he's actually selling it and making money from it. Or Danielle, she's a friend working as a developer from Bolivia while building a mailing list application that makes you unsubscribe from all unwanted emails. Or another thing I found yesterday was this guy, Alexander Sideris from Greece, and he was working on an application that is a Chrome extension that takes all the GIFs you see on your pages and checks if they're safe for people suffering from photo-induced epilepsy. So making browsing safe for people suffering epilepsy. So the community mostly, you can find this on a site called Makerlog or Product Hunt Makers, which are essentially some public to-do lists where people share their tasks and what they're doing. Or you can also find some other more niche communities like Women Make, like Solo Founders, which are some chat groups where people help each other out. So when building these products, trying to reach profitability as fast as possible, the most important thing is getting up and running with the project as fast as possible. The technical details aren't really the most important part when we work on these projects. So most makers work with languages they already know, like Django, like Python for Django, or Rails for Ruby, or Adonis or Sails for JavaScript, or Laravel for PHP. And after learning Clojure, though, I asked myself, how can I be a maker and make products rapidly using Clojure? So I started looking to what we have. And the first thing I stumbled upon was Noir, which unfortunately was dead. Then I came across Pedestal, which had this amazing GIF on the homepage, but then after trying to build something and actually read the documentation was completely incomprehensible. I couldn't do anything with it. But fortunately, I found Luminous, which allowed me to build my first product. Has a very good documentation. It's fast to get started. It has Hiccup out of the box, so you write HTML as a Clojure object. And it's battle tested, so many people built their companies on top of it. The main problems I had with Luminous were that there's no ORM or easy migrations. In fact, you have to connect your database yourself. So you have to import JDBC. Then from JDBC, write your own SQL to generate the tables. And then maybe if you want, you can use Toucan or some other library as an ORM to tell your application what are the models that exist and how you can get them. As a beginner, I found it a bit overwhelming. But at the same time, in the Maker community, I found another developer that was using Clojure, and he was actually developing his own framework called Coast. So we talked a little bit on Twitter, and he taught me how to use it. This framework is called Coast, and the main advantages in using it are the fact that it's fast to set up and easy to learn. It's opinionated, but extensible. So it's not like a framework like Django or Rails where you're stuck with something and can't really move forward to something more flexible. It also has an ORM and an extensible query language, which is inspired by the Atomic. So when you're querying data, you query it like you would with the Atomic. It also has a small footprint, so the amount of files generated in Coast projects aren't that much compared to Luminous, which has a very big footprint. I think when I first started the project with Luminous, I had around 60 or 70 files. 45 of them probably I never touched and have no clue of what they did. So instead with Coast, you just have everything very well concentrated and you know what every piece is doing. So to get started, you have to obviously create a project with this command, Coast, new, and the name of your project, which will create a folder with a basic setup for your application that already runs. But then comes the part of creating a database. So Coast out of the box supports PostgreSQL. So by writing makedb create, you get a Postgres database. Now that we have an empty database, we have to fill it in with either some data or like some tables, some models. So we have an ORM. This ORM supports either EDN migrations or SQL migrations, so you can write your own SQL if you feel like, or you can just write some Clojure object code that then gets generated into a schema. To generate an EDN object with a migration, you type Coast generate migration and the name of your migration, and inside the resources/migrations folder, you'll get an EDN object called the timestamp addMember.edn. Okay, so now that we defined member, which is basically what in every user-based application you have like a login or something like that. So let's create a model for a member. To do so, we write an identifier, which will be, in this case, an email. The type of that identifier, which for an email is case-insensitive text, which is a Postgres extension. And then like a password, which will be obviously part of a member and be a text. After doing this, let's create another model so we can learn how to reference other values from different tables. So let's define a site and then make an application in such a way where a member has different sites. To get this done, you just write dbrel member properties, or the name of the field of your model that you want to have with a foreign key. The type, so if it's a one-to-one relationship or if it's a one-to-many relationship. In this case, maybe a member has many sites. And then a reference, so like a member properties links to a site that is owned by a member. And there are many sites for every member. Or another example is member site has only one member if you don't have many-to-many relationship, but have a one-to-one relationship. So once you wrote your migrations, you have to migrate them, obviously, and apply into the database. With makedb migrate, you get this done. And so now we have an application has a model. We made the architecture of the database. We have to get started and prepare some routes to actually assess these data and have something. So routes in Coast are managed using Clojure, which is, I found, pretty much the standard routing library for web applications in Clojure. A nice thing you can do is defining your routes. You can define the middleware for each route or each group of routes. So for example, here we have a private routes that is wrapped by this wrap authentication middleware, and inside the public routes, which are accessible by anyone. And at the end of the routes file, you can concatenate all the different routes with different permissions. So for example, if I had more than just public and private routes, maybe have admin routes, I could just simply add admin and concatenate also the admin routes. So I talked about the authentication middleware, but this is not something like Django or Rails that does everything for you. You have to actually write your middleware. So to write our middleware, we want to attach to every session a user ID or an email. To do this, we first have to learn how to query data. So queries are datomic style. So this means if I show you this syntax, it should look familiar, kind of. You have a query function where you pass in pull, the values you want to pull from your database, where, which is where, the where queries in SQL, and then you pass through also which member ID, so like which reference is the member ID reference in the where. Another way to query data is using pull. Pull is a function that basically takes a model you're querying with the fields you want, and then an identifier for that field, which is the parent's email in this case. So now we learn how to read data. We need to learn how to create and update data. We do this using the transact function. The transact function operates in a very simple way. So if you want to update the value of something, you pass in a unique ID and the values you want to update inside of an object. If you want to create a new value, you simply pass an object with the values of the model you're defining. So now we got the see, create, read, and update parts done of our application. We need the delete. And the delete is simply you pass delete with a unique ID of the model you want to delete, and it's done for you. So now that we know how to query, read, and delete data, we can write our middleware. So wrap authentication that we called in the routes is basically takes the ring request as a handler, and it appends as a key the member email. So in every request on our views, we'll have an email or an ID, whatever we want to pull inside the middleware. So now that we got the middleware done, we can start writing our routes. Our routes are normally written using Hiccup, which is a representation of HTML as a Clojure object. The main advantage in this is that out of the box, you get very powerful templating language, which is Clojure itself, as manipulating an object is very easy with Clojure. And if you were using something like Rails or Django, where you start out with a templating language like Jinja, which is very limiting, you wouldn't have the flexibility you would have with Coast. So let's explain, though, the routes. So we saw the routes, and the routes are defined as the parents we pass for every route are the method, so get, post, or update. Then we have the route, which is the actual URL that we go and query. And then we have the function we're calling. So, for example, for the dashboard, we're getting the namespace called home.dashboard/view, which is the function we're calling inside of that namespace. And a good convention we found is to call every view with the view function and every action with an action function. Also, another nifty thing is that after the function name of the namespace, you can also add an alias for it. So for example, for our home page, we can have a param called home, and then in every page, if we reference URL for home, automatically Coast will get the URL we need. So, as I told you, having views is the approach to go for defining views, and the URL for function gives you the URL for a specific route with also this aliasing function. And I think that's it. We're good to go to build a Clojure application. For more practical examples of apps built with Clojure, you can find a repository called MageHash, which was the first product I actually built with Clojure. No, the second product I built with Clojure, the first one using Coast. And in the Coast framework repository, you can find a good documentation where writing and actually improving the everyday. I want to thank the people that made it possible for me to give this talk today, which are Sean Walker, which is the original author of the Coast library and a good friend of mine, and Ingo, which was very supportive and helped me pick the topic for this talk. You can reach out at hi@Ferruccio, which is my email, if you have any questions or whatever. And I hope you enjoyed my talk and you're motivated to build something useful using Coast.
So yes, questions. First question here. We have, I think, 10 minutes to 15 minutes for questions.
Regarding makers community,
yes.
There was really good hints. Have you also looked at indie hackers?
Oh, indie hackers, yes,
That's
of
pretty
course.
good. And then a question regarding your talk. What's the approach for authentication and user management? Because these frameworks like Django and Ruby on Rails, for example, Ruby on Rails comes with device and has also like other OAuth 2 plugins, but also like basic like authentication from a user perspective.
Okay, so for authentication, most of the time, what I like to use in this application is just have a session param inside of the in the middleware that you pass in. So it's completely managed server side. As I read some articles saying that JWT isn't maybe the best security standard, but you could actually implement JWT because you have a middleware file inside of Clojure, like inside of Coast, sorry. And from there, you can actually implement or add any library you want. And you can actually opt out from any part of Coast. So a very nice thing I found in Clojure is that you can build your prototype with Coast, but then you can take your hiccup code if you want to scale and turn it into maybe a reagent front end with some work, obviously. And you can turn in your actions and your view functions into actual REST APIs just by changing the code you have inside of a page from some hiccup code to maybe a JSON response.
I think it would also well integrate with Friend or Buddy or any authentication library there already is in Clojure, because it's basically the Clojure web stack just in an opinionated way.
Yes.
As far as I see it.
Thank you. It seemed that you were turning pull expressions into SQL inside Coast.
Yes.
I was just wondering if you could talk a little bit about how you're doing that.
Wait, can you please repeat your question?
Yeah. How are you turning pull expressions into SQL?
Oh, like Coast generates the SQL queries, and you can also, there's a function called the def queue, which, like, if you're not happy with the querying language that Coast has, you can just call this function that comes from the Coast framework and insert your SQL code, and it gets run.
talk. I might be able to guess the answer, but I want to ask this anyway. Do you know why the developer didn't just use Datomic? Why wrap Postgres like that?
Not really sure, honestly. I think the main decision and what we were talking about recently was to make a very kind of controversial decision architecture-wise and to actually offer out-of-the-box SQLite instead of Postgres because of the fact that it's very easy to just create a SQLite file on any repository or any environment. So I think the main reason is probably because in the future we want to have Postgres support if you want to scale, but a basic version of Coast running with SQLite, which for most prototype use cases is good enough.
Thank you. So do you see Coast just as a prototyping thing?
Well, as I said, I think Coast is a good way to get started and bootstrap a project. And then, as it's very extensible and not a very a framework that is sticky and that sets some guidelines for how you should use it, you can easily swap parts for your use case and actually turn it into something maybe just for the backend and recycle your hiccup code to have a Clojure script front end maybe.
Okay, so
That's how I see it.
I know in Luminous you can really mix and match with the profiles. You can choose for different routing and whatever. Is this what you mean when you say you can change things up?
Kind of. I think that it's something more left to you than built in the framework, because the framework goal is to be as light as possible.
Okay. And maybe finally, how do you see them coexisting, so Luminous and Coast?
Well, I think the audience is very different. So I see Coast as kind of a gateway drug to Clojure. So you get into Clojure to build applications in a very rapid way with a lot of support with screencasts and stuff like that, with a very opinionated, structured approach. And then as soon as you learn how to use it and build stuff, you're free to go and can swap pieces. So like when I first learned Luminous, I found the learning curve very steep. Whereas if you see what I explained in Coast, with what I explained, you can basically make most CRUD applications.
Are there any more questions left? So then I have a question. Did you have a look at Chestnut, which is basically just pre-configured Clojure libraries as a lining template?
No, not yet.
No, you didn't. Okay, then maybe you should have a look at Chestnut. Okay.
Thanks a lot.
I saw that you actually have a command line Coast. Why not have like a landing game template? Or why did you decide to go with your own CLI?
I don't know, just there was a decision made at the beginning not to use Leiningen or boot or anything, and you just use make comments. So like the REPL, you started with make REPL. And I don't know, like at the moment, we're also thinking to finally implement the Leiningen version of Clojure. But at the moment, this approach works pretty well.
And then how do you do dependency management, or like if you don't use Leiningen, what do you use, like Clojure deps?
You have the NEDN, deps EDN file.
Okay, thank you.
Anyone?
Well, that's good enough.
That's good enough, yes. So, let's give another applause for Ferruccio, please. Thank you.
Thank you, everyone. It was really a pleasure.